Hello and welcome to another lesson from Simply PE, this time in synovial joints and joint types. So just a reminder with these presentations, the yellow text boxes are the tasks for students, the green text boxes are the note-taking sections for students, the blue sections are the differentiation tasks, and the red text boxes are the teaching and learning strategies and ideas for the practitioner. So in regards to this specific topic, reminder that the syllabus requires you to understand the identification of synovial joints and the components within them. So we need to know about the structure that makes up a synovial joint. We also need to know how these components help to prevent injury to the bones, okay? Because it's really important, isn't it, in sport that we try and prevent injury as much as possible so that we can actually play the sport. And finally, understand the two joint types that we need to be aware of for the syllabus and where they're commonly found within the body. So without further ado, let's get going with this topic. So, synovial joints, you should be able to see the diagram here on the right hand side. In a minute I'm going to ask you to sketch it, but before we do that, let's try and break down as to what some of these keywords are and what specifically they do within a synovial joint. So ultimately a synovial joint is the most common type of joint in the body. Okay, so we look at movable joints within the body. The synovial joints are the most commonly found within the body. And ultimately they have characteristics, each of them, to determine what makes them a synovial joint. So first and foremost, synovial joints have synovial fluid, okay, between the cartilage pads. And if you look here on the actual diagram, okay, you'll be able to see the synovial fluid is in this kind of turquoisey blue colour, which is found in the middle of the joint. Okay, the light blue pads here, they obviously represent, as you can see labelled on the diagram, the cartilage. Okay, and if we remember, we talked about the cartilage, they're sort of this protective layer that protects the ends of the bones from rubbing against each other and so on. So they obviously provide protection from ensuring that there's no discomfort there. These are kind of like the shock absorbers of movement that occurs obviously in our daily life and in sport in general. So within this diagram, you can also see that synovial membrane. Okay, so this is represented in that yellow, thin yellow strip colour. Okay, this lines the joint capsule. Okay, and you can see the joint capsule just here, just above or beneath, if we're looking at the top layer here, okay, of that synovial membrane. Okay, so this capsule here again encompasses obviously where the joint sits, okay, and obviously we've got the membrane, which is this outer kind of lining. And the synovial membrane, as it says there, it produces this synovial fluid, as we talked about earlier. Okay, so it's important, obviously the membrane, okay, produces that synovial fluid, which is obviously required within the joint. And as it says here, the synovial fluid produced by the synovial membrane is there to lubricate the joint. So if you think of, I don't know, you think of a joint, I suppose, in terms of what you might find in your house, for example, like a joint you'll find up by the door, okay, in order for the door to open and close, okay, that joint, in order for it to open and close smoothly, sometimes requires things like WD-40, doesn't it? Okay, it requires some oil, okay, and that kind of oil loosens up the joint and ensures that there's no friction, there's no tension there, it's able to open and close easily. And this is what that synovial fluid does as well. It provides that lubrication to ensure that the joint, you know, is flexible, is movable, okay, and is able to kind of move in the directions that it needs to, and that range of movement can be greater. Again, you can pause the video here, and I think it's really worth just sketching that diagram, okay, with the parts labelled for your benefit. Okay, so let's move on. We haven't obviously identified all the parts within the synovial joints yet, so let's include a few more things. So the ligaments, okay, we'd have seen there on the diagram as we go through, as you can see here, okay, the ligament you can see on the right hand side of that diagram, that represents the fact that the bones, okay, join together. So ligaments join bone and bone together. So you can see here that red lining, okay, attaches one bone to the other. Okay, and same on below here as well. Okay, so ligaments are crucial in ensuring that bones obviously can link together. And ligaments obviously provide that strength, that stability at the joint. Okay, so it helps to prevent dislocation. Dislocation can still occur, and sometimes when dislocation occurs, when we get injured, for example, we've got to be careful that it doesn't cause damage to ligaments, because obviously a ligament damage can be a severe and can be a kind of a long-term injury, okay, for invasive sports and any athlete for that matter. And then we've got this concept here, this word bursae, okay, where we're looking just below here in this light blue thin strip, which represents small bags of synovial fluid, okay, and again this surrounds the joint and it helps reduce the friction in a joint. So sometimes when we get joint pain, it can be from this kind of small bags which can become inflamed. Okay, so that can be a reason why sometimes we get joint pains and sometimes we get inflammation from here. But this again reduces that friction. Okay, so it's another example, not only the synovial fluid, but also this bursae and these small kind of bags which help to reduce friction to ensure that that movement is more fluid within the specific joints. That range of movement can be increased. And then finally, we've got the joint capsule itself, okay, which is just here and just here at the top of this diagram, as you can see just here as well. Okay, and these are tough fibrous tissues. Okay, again, the structural kind of surrounding, excuse me, of the joint, which supports and supported by the ligaments, as we've just talked about above. Okay, so this kind of joint capsule kind of really solidifies, ensures that that structure is in place to surround the joint so that it's in one piece together. Okay, so let's move on to hinge joints next. And for hinge joints, we need to be aware that they basically provide the movements of flexion and extension. Okay, so as I talked about, I think on a previous slide before this, okay, it's a bit like a hinge on a door. Okay, when we think of a hinge joint within our body, okay, it's very similar to the hinge joints that you might find in your own home. And ultimately, if we remember what flexion is, okay, it's that movement of where the angle between bones reduce. Okay, so it's where we are reducing that angle. And for extension, we're looking at the movement where angle between the bones increase. Okay, so if you think about putting out your arm just for a minute, okay, and if you put out your arm just to either your left or your right arm in to the side of you, okay, and when at the elbow, for example, okay, because the elbow will be an example of a hinge joint, if we start to flex about halfway, okay, our forearm, our hand towards our shoulder, okay, then ultimately that flexion is reducing the angle, okay, between the bones. Okay, so that's the flexion phase. If we keep on going, we should be able to get to around about a 45-degree angle. Okay, and when we extend all the way and we straighten out our arm to the side of us, okay, that is roughly at about 180-degree angle. Okay, and that's where we're starting to increase that length, and that's the extension phase. So, can you think of any more joints that you might find in the body which are hinge joints? Well, I've just given you one, haven't I, in terms of the elbow. Can you think of another one? So, another example you could have come up with is looking at the knee. Okay, so again, in the diagram below, you can actually see that kind of taking place, the hinge movement occurring. Okay, so these are two examples. We're going to go through that in a bit more detail in a separate video where we'll look at the joints in action more specifically. Alright, so let's look at the next joint type that you need to know for the syllabus, and this is the ball and socket joint. Okay, so here, this type of joint provides the greatest range of movement at any joint within the body. Okay, so that's one of the key things that you need to be aware of. And they provide us with examples of flexion, extension, abduction, adduction, and rotation. So there's loads that they really provide in regards to the range of movement at this specific joint. But due to the fact that there's this large range of movement, these type of joints are more susceptible, they're more likely that you might cause or have a dislocation from. Okay, because obviously they kind of move in all different ways. Okay, so there's not as much stability in the ball and socket joint. Okay, because there's that big range of, or because there's that, there's that different types and different ranges of movement in essence. So can you think of any examples of a ball and socket joint within the body? Okay, so the key examples you could have come up with really is looking at the shoulder. Shoulder is a key example of a ball and socket joint. And ultimately, if you think of the shoulder, and again, this is kind of looking at you to do a bit of movement here, but if you actually raise your arm forward and straight, okay, that's an example of flexion, okay, within this ball and socket joint. If you then take your arm back, so a bit like a sprinting motion, so when you're running, you think of what you do with your arms, okay, you raise your hand forward and upwards, and then you raise it back. Okay, that would be an example of the flexion phase, going upwards and forward, and then back, okay, would be an example of extension. Okay, and then again, if we think of the shoulder joint and we're moving our arm now out away from our body, that's abduction. Moving it back towards our body, that's adduction. And then rotation, again, if we just put our arms straight down by our side, and if we rotate our thumbs in towards our hips, okay, that's the example of rotation. Okay, and we can actually feel that at the shoulder. If you do that movement, you can actually feel your shoulder joint, your ball and socket joint, okay, rotating. Okay, so worth doing that and worth just feeling around your shoulder joint there, okay, to see the type of movements that occur. The other example you could have come up with is looking at the hip. The hip joint is another example. There's a challenge task there for you. Pause the video here and see if you can think of any sporting actions used in the ball and socket joint at the shoulder. Okay, so examples, as I said before, in terms of sprinting, the flexion and extension when we're pumping our arms forward and back, that's a key example you could have come up with. Okay, you could have talked about abduction, so they're away from the body, like fencing, so when we're prodding our sword towards our opponent. Okay, adduction, can you think of any? Can't think of any on the top of my head actually, so it'd be worth you hopefully writing something down. Rotation, you could have talked about I guess a tennis serve for that matter, or even a tennis shot if you're playing the forehand, okay, and we're actually putting that topspin over the ball, that would be an example of rotation as well. Okay, some revision questions for you. I'm not going to read them out, but I'll let you pause the video here and see if you can answer these. Okay, so hopefully you've come up with some answers for these revision questions. The answers are now on the screen. So cartilage acts as a cushion between tendons. Is that true or false? The answer is false. Cartilage acts as cushions between bones. Okay, question 2. Excuse me. What structure encloses and supports the synovial joint? The answer is a joint capsule. Question 3, what do tendons do? They attach muscle to bones, okay, to allow bones to move when the muscle contracts. Okay, ligaments, remember they're the connective tissue for bones to bones, and they provide the strength and stability at the joint. Okay, what about say, and what do they do in the synovial joint? You can see they're the fluid-filled bags that help reduce friction in the joint. And then question 6, how does the synovial membrane prevent injury to the bones in the joint? Remember, they provide that lubrication. Okay, so they provide that fluidity, that range of movement that's helpful to prevent the injury to bones at the joint. And then finally, for the teaching and learning practitioners, out there in terms of what you can do to help you. Ensure you get students to label diagrams, okay? Explain them. Make sure you use true and false just to solidify their knowledge. Cross-relate it to using muscles as well, and the movement aspects as well. Best of luck with this task. Thanks for listening.